Hello, ladies and gentlemen. We're back to the second part of our order of operation absolute value notes. We've already discussed the distance from zero on a number line is the definition of absolute value. And when you see it, you say the absolute value of -2. For our first example here, I made a misspeak in the last one. The absolute value of -2 minus 3 is the absolute value of -5. And then we look and say how far apart on a number line is -5 from 0, and that of course is 5 spots away. Distance is always positive, and since absolute value is a distance, that means that our answer to an absolute value problem will always be a positive number. For our example 2, we're looking at the absolute value of x is equal to 3. So we're kind of solving for x like we would in an equation. So what we're doing when we look at this is we're asking ourselves how many numbers, what numbers are 3 spots away from 0 on a number line. So when we think of a number line with our 0 in the middle, we know that x could be 3 spots away, and that would be a value of x is equal to 3. However, on that number line, if we go 3 to the other side, we know that -3 is also a potential solution because both of these answers, both 3 and -3, are 3 spots away from 0 on a number line. So whenever we have an x inside of a set of absolute values, you are going to 99% of the time always have 2 different answers. So we're going to bump up this level of difficulty by 1 for our example 3. We're going to have more of a problem, not just the letter x inside our absolute value. So we know that the absolute value of some number x plus 4 is equal to 5. So we are going to go ahead and take a look to see what x could possibly be that will end up being 5 spots away from 0 on a number line. So when we see this type of problem, we immediately split that into our 2 different options. We want whatever's inside our absolute value here, or our blob, to be either 5 spots away, which is going to be 5, or -5 spots away, which is also going to be 5 for our absolute values. So we're going to split this actually into 2. So our first one is x plus 4 is equal to 5. So if we get that middle to 5, we know that's 5 spots away. And our second one is going to be exactly what's inside our absolute value, x plus 4, but we want that to be -5. Because if we can get it to equal to either of those, 5 or -5, they're both 5 spots away from 0. At this point, we're just going to solve normally. We're going to subtract 4 from both sides, and so we have 5 minus 4, which is 1, or when we subtract 4 from both sides, we have -5 minus 4, which is -9. So if I plug either of those x's into here, then we know that both of those are going to be equal to 5, and the absolute value of 5 is 5. Or when we plug in that -9, that solution is going to be -5, and we know the absolute value of -5 is also 5. Our very last example is one that's a little tricky. So I know that I want to plug something in here to make it -3 spots away from 0 on the number line. So this is actually the trick. We know that if we've isolated our absolute value alone on one side and we have a negative number on the right, then there is absolutely no solution. The reason why there's no solution is because, once again, absolute value is a distance, and a distance cannot be negative. Now, we have to be careful. We can only make this assumption when we have on the left-hand side only the absolute value. We have to solve and isolate that first. So this is a little review, a little overview of absolute value, and we'll be working on this a lot in warm-up, and we'll be working on order of operations for the entire year. Once again, these notes need to be on the right-hand side of your math notebook, and then we'll have all of our work and warm-ups on the left. Thank you guys so much, and I will talk to you in just a minute. Have an amazing morning.